let's just start diving in. So I want to teach you a little bit about what is Unikernel and why I think it will be the next thing. So let's understand first where it's coming from and what is the motivation for it. So this is the stack the way people today is running it, right? I mean, there is the hardware on the beginning. On top of it, you're putting your hardware drivers because it's part of your hypervisor usually. You have the hypervisor. Then you're putting a guest OS. The guest OS, you have also drivers. Then you have the operating system is supplying you user processes, right? Then on top of it, you're putting Docker container. And inside the Docker container, you're putting the shared libraries, the language runtime, the application, and the application config, right? This is what we're running today every time that we want to run a simple process. And that makes a lot of sense, but the question is, what are we trying to do here? What are we really, really trying to do here? And we need to remember that the only thing we're really trying to do is to run a single application on a single user with a single server, right? That's all. Like, I mean, basically all we want is just to run one simple application. And there is a lot of redundancy in the stack, right? If you're looking at the stack in terms of the isolation, for instance, you have the isolation of the hardware itself, which is physical isolation. Then you have the isolation of the hypervisor, basically isolate virtual machines. Then you have the isolation of the processes, right? Then you have Docker, who basically kind of doing the same, right? Isolated the processes. And then you have an application. Isolation on the application, on the user level. And that's kind of like overkill. The question is why it's so complicated. For instance, why the kernel is so complicated. And the answer for that is that the main job for the kernel is to protect, right? The operating system is there to protect us, to protect user from user, processes from application from application, and user from application, right? That's our job. And that makes a lot of sense on the 5060. When we were running a big computer, mainframe, right? It was very, very expensive. We couldn't afford ourselves buying, a big main computer and just use one application. So we needed to share. And then there was the timing share computer in the 50 and 60 that I need to make sure that if I'm sharing the computer with you, you're not going to run on my memory or kill my application. I will not do that for you. So we needed to do all this orchestration of the operating system because we had to protect. But that's not the case anymore, right? We're not doing that anymore. We actually can today buy a very cheap computer and run our application or run it in the cloud. But we still have all those governments and separation on the operating system. If you're looking at the microservices architecture, where everybody talking about it, Docker kind of like bring it to the front of it, there is a lot of duplication and a lot of sharing there in the microservices. So if we're looking, for instance, on something like etcd, it's basically exactly the same like ets locally. So there's quite a lot of which kind of trying to do what we've been done for Linux already. The kernel includes a lot of drivers, and mainly we don't need them. Like for instance, in my laptop, I'm running the floppy driver. I'm not going to, no one using floppy. You still have the bit and the byte on your computer. Same thing with USB when you're running on the cloud. You can't get to the machine, you still have the bit and the byte on your operating system. And the last thing is that all the model of yum install, it's not yum install or get up, it's not really efficient. You're just getting a lot of junk to your machine. You don't know what you're getting, what you're not getting. A lot of the stuff you don't need, it's not even running. It's still getting a space on your disk. And in terms of security, that's caused a huge surface of attack, right? Because there's so much stuff there that we don't need, that me as an hacker can think about penetrate, that it's harder to actually secure that kind of a huge surface of attack. And the other thing is that the microservices architecture is sharing a lot of stuff. You're sharing the kernel, the memory, the file system, the hardware. And the only thing that's really protecting us is something called cgroup. But I like to say that it's like you have a house with the doors and windows, and what you're doing, you're putting a lock. People are still going to get in, right? So it's a little bit problematic approach. If you're looking at the Linux kernel itself, language, like this is the language that one needs to know in order to maintain, right? It's going on and on. This is all the technology that you need to know in order to maintain the Linux operating system. And that's quite a lot. There's not a lot of people who are actually capable of doing it in the world. And if we're looking at lines of code of the Linux kernel, you will discover that, I mean, this is by definition of big application versus small application. So let's say that small application is 10K line of code. Medium to large is like 100K. And let's say that really huge one is 1 million, right? I think it's fair. This is the number of lines for the Linux only kernel. I'm not talking about the distro, right? 22 million lines of code. If you're looking at the distro itself, Debian in that case, it's actually 419 million lines of code, right? This is huge, and this is like people, to reason about it's almost impossible. So I think that there is a lot of inefficiency in the stack the way it's today. And the question is, how did we get there? Why it's so inefficient? And the answer, for my opinion, is pure evolution, right? We started all the way on the mainframe, went to the personal computer, all the way to today, Internet of Things. And guess what? All of this has one thing in common, which is the Unix. So what can Linux run on? Anything. What can run on Linux? Anything, right? I can take the last Debian distro and install it on Pentium 1 10 years ago, it's just going to work, right? I will not need to do anything to configure it. It's going to work out of the box. Which means that as a community, we basically make a choice. And our choice was that we prefer to be compatible versus efficient, right? This is basically what we're doing. I think we can do better. And that's why basically I think that Unikernel is the next thing. So it is working, right? I mean, Facebook is running, and all the Google and so on, they're running crazy hyperscale microservices, but we can make it right. And that's why I suggested. So the question is how to, right? I mean, okay, it's very interesting. We see a lot of inefficiency. How are we fixing it? I mean, are we going to, what do we need to do to make it better? Are we going to rewrite the operating system? Well, it's kind of complicated, right? Does that make sense to actually write a new one? Probably not, right? But I think it is, actually. This is a quote from Linus, the guy who wrote the kernel operating system. And this is a long argue between microkernels versus monolithic operating system. But what I want you to see is the last thing that he said on the blue. And basically what he said is that the kernel is basically something quite easy to write, and someone can easily do it without any knowledge in 1 year, right? So that's what he did. And this is exactly what the Unikernel ecosystem did. They they wrote a new Unikernel. So let's understand what is Unikernel and why it's so good. So this is the traditional approach today, right? You have the kernel, you have all the OS libraries, and you have your application on top of it. No matter which application I'm running, it's always the same stack, right? Always have all these OS libraries and the kernel. But the Unikernel is saying, what if I will take only the application and see what it really needs? For instance, if it doesn't need a floppy driver, I'm not going to put it there because it's a waste of resource. And I will take only what the application is using. If it's using network, guess what? I'm not going to have the driver for the network. And then create, basically, wrap it as an operating system. So in the Unikernel approach, you will take only what you need from those libraries. They're not going to be all the libraries, only what you need from the kernel, and basically wrap it as a Unikernel. So how can we do it? Why it's so interesting? So basically, Unikernel is when we make the decision of architect Unikernel, the decision that we made is we're going to support only one process and one user. If we're supporting only one user and one process, that means that we can actually be very selective about what we're putting in there. For instance, we don't need to do permission check because there is no multi-user. And for instance, we don't need to do a multi-address space because, again, there's one application with one space. Why do I need to do all this mess? I don't need the rings, right, the kernel rings, because I can actually run the application on the kernel mod. And the reason is because that's the only thing that's running there, so there is nothing to protect. Why do we protecting? Why there is the rings? Because I need to make sure that if I'm running my process and you're running your process, my process is not doing something nasty to the operating system, to the host itself, and then killing your process, because you will be affected. But if I'm the only one who's running there, even if I will kill it, I will kill my application. But that's it. Nothing else will be influenced. So now if we're actually making this choice, we can be very smart about taking out what we don't need. And you will discover that we don't need quite a lot of stuff. So That's basically what it's saying. You don't have a context switch. You don't have a multi-user, kernel mode or user mode. And you can be very thin about what you're putting in your operating system. Okay, so how are you building one? So it's quite simple. You're taking the drivers, because I need to know where you run on, taking the language runtime, your application config, binary, and dependency, putting in some magic tools, and then we're creating the Unikernel. And Unikernel, it's basically a bootable image, right? So you can run it on bare metal. But you know what? It doesn't really make sense because it's very, very thin, right? I mean, I'm talking about a website of 56 meg. You're not going to run it on bare metal. It's just a waste of resource. So you run it on hypervisor. And the hypervisor is giving you something very unique that the operating system usually not giving you, which is a hardware separation, right? So it's basically the CPU is separated. So it's very, very secure, much more secure than to take a regular bare metal, operate the system, and then put Docker on it, for instance, because you don't have the physical separation. And it's a machine, so you can continue using your own hypervisor, and everything that you're doing will look exactly the same. You want to do vMotion, it will work. You want to support storage, it's already working. We don't need to reinvent any wheel because it's a VM. Yes, and then what we basically did is just took what we don't need from the stack, right? There is no need for all this middle layer, so let's not use it. What we're going to do is going to take the hypervisor, and basically we'll create very, very little wrapper of operating system around your application. So it's much easier to reason about, less, I'm talking about 2,000 lines of code for the operating system, very, very slim. The performance will be better, and so on. So again, here I'm just showing that the stack is much smaller. And here what I'm doing is I'm basically wanting to show you, again, it's very important that you understand, because a lot of people are saying, well, why should I just take bare metal, put operating system, and put Docker inside? And the reason is because you're not getting the separation. And this is key. You're not getting hardware separation. So let's just summarize the advantage of Unikernel. The first one is there is no multi-user support, right? So running only your user admin. But you can do multi-support for the application itself, right? So I mean, you can serve a lot of users, just not the operating system. No permission check. You can utilize 100% from your actual resource because you don't need to context switch all the time. Isolation only on the virtual hardware. You only share hardware. That's the only thing you're sharing. In terms of size, the minimum operating system today that probably people will run will be 1 gig. We're talking right now about megs, as I said. Like basically, the size of your operating system is the size of your application because we're not putting any add-on. Very short boot time. It's much shorter to boot 2,000 lines than 419, right? Million. And the other thing is that it's also the custom of attack is tiny. But it's also custom, and this is clear. So it's not only that it's very hard to penetrate, it also means that that every machine will look differently because the libraries will be different. So even if you manage to actually somehow penetrate to one machine, it's not going to work for you for the other because the library is not going to be there, right? Mainly. Could be, but usually not. So much more secure. And the last thing is it's really immutable infrastructure. People are talking about immutable infrastructure today. This is a real one. If you want to change your code, you're rebuilding Unikernel, right? There is no point of update where you cannot SSH to the machine, right? It's a really immutable infrastructure, which working very, very nice with the architecture of the microservices. So for your knowledge, there is 2 types of Unikernel in the industry today. One of them is what called language specific. So Docker, for instance, acquired a company called Unikernel System, which writing their the Unikernel, it's called Mirage OS. They're writing it in OCaml, and that's the only language you can run on it, right? So that means that, if you own an application in C, you need to rewrite it. So that's why it's forward compatibility. And there is a few. There is Include OS, who's supporting on C++ and so on. On the other side of the thing, there is the PaaS and compliance ones, like RAMP one, for instance. And that means that you can run everything that you want. So we, for instance, running Go, C++, C, Ruby, Java, whatever. Name it, we can run it, right? Every language that you want. What I wanted to show you here is the benchmark, because that's a question that usually people ask. So what I have here is, so there was a company called Cloud in Israel, and they wrote a kind of Unikernel. It's not really a Unikernel, but it's kind of, they're kind of like putting way too much stuff there, that call OSV. And when Dockers got out, they panicked a little bit, so they decided to pivot. And the way they did it, what they did, they basically decided to take Cassandra, rewrote it, and run it on Unikernel and get a killer performance. So they did actually. It's called ScalarDB, and what I wanted you to see that it's actually 10 times faster, right? So I just want to give you the idea of how we can get better performance. I will skip this slide, and I will go to talk about what we did. So as I've been introduced, I'm a CTO of the Cloud Management Division, but I also pick 2 people from this team, and we're running advanced development, right? So we're doing some crazy project. That project is coming from there. It's called Unik. And the idea is that when I look at the architecture of Unikernel, I said, oh my gosh, this is like the future. This is amazing. This is how it should be done. And why people are not using it? And then I realized that the reason people are not using it is because it's very hard, right? You need to take the drivers and understand the scheduler and to put it and what you need and what you don't need. It's very, very complicated. So, and that, if you think about it, is exactly what Docker did to container, right? Container was always there, or a long time ago, and they only become very, very popular after Docker make it very easy to use. So that's what we decided to do for Unikernel. So that's what is Unik all about. It's a platform that you can build and then run Unikernel. It's a little bit more, because when you're compiling it, you need to tell me which driver you want, which environment, or which provider you want to run. So we're also running it on the provider for you. So it's a little bit doing more than what Docker is doing, but basically that's the idea. You give me my code, and I'm giving you Unikernel running on the cloud. It's waiting in Go. It's an open source project that we open sourced 6 months ago, and it's actually going very good. We have a big community, over 1,000 stars in GitHub and so on. So I recommend you to go check it out. So how does it work? As I said, it's so simple, right? You're basically building it, and when you're building it, you give me your code. You tell me which Unikernel type you choose, because we are not opinionated. We support all of them. Which language you're coding, let's say Go, and where you want to run. The provider is basically where you want to run. I want to run on AWS, for instance. And then the name of the image that you're creating. We're compiling it for you. And then what we're doing after it is just run. So to run, you tell me, here is the image that I want, and here is the instance name. That's simple, right? And I will show you a demo in a sec. But that's, for my opinion, is the most important slide. I think Unik is very well because the way we architect it. And the way we architect it is basically, we decided that it will be no opinionated. We really, really got inspired by the Kubernetes architecture, which everything separate very nicely with interfaces. And we have 3 major ones. That's what I'm describing here. First of all, it's the Unikernel type. So as I said, it was very important to us that the community will let support for more Unikernel. We cannot do it with 3 people, right? We cannot do it by everything together by ourselves. So actually include OS, for instance, is support for include OS themselves, right? They just do it. So it's so clean and so easy that it's very, very simple to add support for new Unikernel. And same thing is for the cloud providers. So today, Unik support OpenStack, VirtualBox if you want to run it locally, AWS, Photon, which is the VMware new scalable vCenter, and QEMU if you want to run it again local and do some more debugging, and a KVM if you want to run it. And also Zen. I'm missing an icon for Zen. And besides that, we also added for Google Cloud. So basically, we can run basically everywhere besides on Hyper-V, and not for a good reason, just because we never put our mind to do that. The last thing is the platform, so the processes. So what I realize is that it's not only very, very, very nice to run it on cloud, it's actually the quality of the Unikernel makes a lot of sense for Internet of Things. Because 3 reasons. One of them, it's very secure. It's important in Internet of Things. Second of all, it's very small. So basically, you're not wasting storage, because in Thing, you're actually carrying that, right? You want them small. You're not wasting storage on operating system and component that you don't need there. And the last thing is that it's the performance very, very good. So I understood that it will be like this. And because ARM is the main, the main platform that people are running in Internet of Things, it was very important for us to run on an embedded device. So we added support for that. And we also created a Unik hub. And the idea with Unik hub is exactly like Docker hub. The idea is that not always the guys who are actually creating the Unikernel will be the one that's running it. So it's a great way to share, right? And we're creating community around it. So I don't know, I want to run Redis on it. No, someone already did it. I can just download it. Okay. Then, when we look at the ecosystem and say, okay, so we're kind of like going to be, to say that it's very important to do something that no one, heard about it. So we need to expand where is the place in the community. And the first thing that we noticed is that everybody really liked the Docker API. So we didn't want people to need to change the scripts and the stuff that they're doing. So what we did with Unik, we basically teach Unik to talk Docker API, that you will not need to change your script. So we basically use the -h flag on Docker. You can target the remote Docker daemon. Now you can connect it, target a Unik daemon, and then basically Unik is translating on the back and doing what it's needed, right? Now, one limitation to it, of course, Docker is infrastructure independence, right? When you're running a Docker container, you don't care where you're running it. You only care which operating system you're running it. Unikernel are not like that, right? We need to know where we're running because we're putting the driver, right? So therefore, the API are different and they should be different. It doesn't make any sense, one API for Docker, for container, and for Unikernel, because then you're getting a very weak API to kind of like cover the both of the states. And therefore, this trick that we did is we work only for run, right? It's not going to work for build because it doesn't make any sense. The parameters shouldn't be the same. It doesn't make any sense. So just put on that. And we also decided to integrate with other stuff, like for instance Kubernetes, because in the end of the day, you need creating Unikernel. And Unikernel are like Docker container, which means that you can create them, but then I don't know, they are not, Docker itself is not in charge of scaling, and it's not in charge of making sure that it's the health of them and so on. So we wanted to leverage the container cluster, and we went to Kubernetes. We also integrated with Cloud Foundry. But the idea is that, you're running, before you would be able to run in the pod. You could run Docker or Rocket. Now you can also run Unikernel. So how did we do it? I would just give This is actually the slide for KubeCon, so it's a little bit more Kubernetes-oriented. But the idea, this is the structure, this is the architecture of Kubernetes, and what we did is that the kubelet, instead of actually creating a local container, is going to Unik and asking to spin Unikernel. And the beauty of it is that, think about it one second. There is one problem today that people are trying to attack. If you have the container, you can scale. But those containers are running on operating system. So somehow you need to be able to scale also the operating system, the host itself. So I think Docker came with Infra Kit, and in Cloud Foundry something called Bosch, and Nomad doing something like this for Mashicode. But in the end of the day, this is a problem because you basically have two layers that you need to maintain. With Unikernel, you don't, right? Basically, what we did, you don't need to, it's on demand. Every time you run an application, it's a small one, boom, you will get it. You don't need to actually take care to another thing below, because there's not another thing. This is the VM. It's just really, really clean and small. So I think this is very, very cool, because now you don't need two tools to actually support that. I have a demos. Should we continue and then do demos? Let's continue, and then I will show them on the end, okay? So as I said, I'm a big believer that Unikernel will be a big, big player on the Internet of Things in the future. I think it just makes sense. There is no sense to run a speaker wireless and put a full operating system when all you need is one application today. It just does not make sense. And that's what Son is doing, for instance, right? It also doesn't make sense to run it when you're doing a self-driving car, because it needs to be extremely secure. It's so dangerous. So there is a lot of use cases that I think that makes sense for that to run. But I didn't like just to say, I wanted to do. So our future is ours to create, and that's exactly what we did. So in a previous conference, and I didn't bring this one with me just because I didn't want to bring the toaster, but basically what I show is how Unik is making me a toast, right? Basically, it's very simple. What we did, we attached Raspberry Pi to a switch that connects to the electricity, and then I'm asking Unik to make me the toast. It's making it a toast, and that to envision how it's going to look. And it's funny because actually what I wanted to show here is that when we tried to do it on the first time and take the Unikernel and put it on the Raspberry Pi, we just saw a black screen. Couldn't even debug it, nothing. And then what you see here is that we attach the GDB and we start actually to debug it and make it work. So all I'm saying is not simple work, but we done it, so it's cool. And it's actually so everybody probably heard about the last attack or the DDoS attack that took all the internet. I'm assuming everybody know about it. And actually, I wrote a blog, and me and my colleague, and I really recommend you to go and read it. What we basically did is went over all the method that today hackers are using in order to attack machine and show how none of them is clippable for a Unikernel. So basically, if those devices on this attack were using Unikernel, it will never happen. This attack will not exist. And I have also a very cool demo to show how it's working. Another interesting thing, before we kind of we'll go to see some demos, is that Microsoft published that they managed to run a .NET on NetBSD. This is fantastic news for us, and here is why. So we're mainly using ROM1 because we believe that's the best Unikernel because it's POSIX compliance and it supports the drivers on NetBSD. So it's very scalable for us because we're basically leveraging the code that they did to run on every environment. So now, if basically they made a .NET run on NetBSD, what I need to do is to take the .NET and run it on Unikernel, because it's not going to be that hard for me. Now think about it. .NET is an interesting market because they're not using Docker too much. And you're paying license for Windows. You will not need to do that with Unikernel. And so basically we're giving the agility of DevOps without paying license, which I think this was like very, very cool. Besides that, if we're running it on Internet of Things, so think about it, we have the Internet device, and basically that's the driver they're running, and then there is the POSIX, so I can put whatever I want on this. So basically what I can do is take a C# developer and make him run an embedded device software, right? Reading in C++. So now everybody can run an embedded device, which I think is really cool. The last thing what I wanted to also talk about is the serverless, so function as a service, or the Lambda. I don't know, there is a lot of name to it, but basically they're all saying the same thing, which there is no point to actually let the server waiting for people to make an API call for it, because we should just run the function when actually we need it, or someone make this API call. And Lambda, I don't know, the reInvent was last week. It was crazy announcement around it. That's the future of the cloud. And the interesting thing about it is that Docker container is not quick enough. When they actually implement or most of the container are not quick enough. So in order to make it quick and efficient, what they're doing, they're reusing container. The beauty of it is that with Unikernel, you don't need to do that because it's booting so much faster. So basically, it's more secure and booting faster. So that's, for my opinion, it will be the future of serverless. This use case is working a lot for the NFV world, the network function virtualization, where they're using VM and basically spinning up machine, killing it, spinning up, killing it. So that would be a very interesting use case. We open source, I said. We have a community, so come join us. I mean, I'm the marketing person. As I said, so we have a GitHub. It's actually over 1,000 right now. I created a unique Twitter account. There is all the announcement that I'm making is there. And also, we have a community in the Slack. People coming, ask questions. We are helping them. And this is my team. So they are amazing. And the last thing is that that's it. So let's do C demo because I have 5 minutes, okay? Okie dokie. So the first demo that I will show you is, let's start with this. So I'm SSH to a machine in AWS and there is a Unik install on it. One second, I will do it bigger, 1 sec. Can you see that? Let's do it this one. Okay. So there is Unik running on it, right? This is a regular command line. What I will do right now is I will do Unik PS to see if there is any Unikernel running already, and I see that there is none. So now what I will do, I will see if I already built some images. So Unik images will tell me that there is 3 images that I overbuilt before. So let's start running one of them. For instance, let's do Unik run, and run the one that oh, this is the Minecraft actually. I wanted the other one. 1 sec, guys. Oh, come on. Unik run. Okay, so what I'm running here is just a Unikernel. I give it the name Idit, which is my name, and I'm using the image that I built before, Node.js. So it will be a Node.js website. And I will click, and you will see that the Unikernel is up. So the website is up. That's fast, right? So now what we can do is Unik PaaS, and it will disappear. And then we will take the IP address. And I want to show you what I just built, what I just ran. So I'm just opening a regular browser, and it will be 8080 because it's Node.js. A second. Let's see, it's pending still. Oh, it's still pending. Oh, come on. Yeah, that should be running, so just refresh it. Don't do this. Okay, so here you go. So this is a website, right? So this is a Node.js website running. You see this one is a regular website. It looks just something that we looked. But what I wanted to show you that's special about it is this is 56 meg running on Amazon. This is an instance of 56 meg, right? That's all. And this is a website that you can click and look and watch movie and so on. So I will dare you that there's probably not a lot of website like this, so thin and let's see. So let's do something else. I don't know, are you a fan of Minecraft, or should we skip this demo?
Yeah, do it.
Okay. Okay, so what I'm going to do, I will build, we wanted to show that it's cool, so we build a Minecraft demo. Come on. Okay, let's do this one. So Minecraft demo I did, I think it's good, hopefully. Yep. Is that the name of payments? Hopefully. Okay, so now what we're going to do is this. So you see I have 2 of them running. We just need to go and open Minecraft. Okay, so now what we're going to do is just do multiplayer. We're going to here, we're going to add a server, we're going to put the IP address, let's just give it a name, LISA, and then we're going to put 54.237.129.151. And we add it. That will be this one. And in a second, hopefully, we will be able to connect. Not yet. What did I do? For God's sake. Fresh. Maybe it could be that I built the wrong image, and that would be embarrassing. Oh, yeah, this is up. So, okay. So what you see is me playing Minecraft, right? So this is a Unikernel and much better performance. I don't know how to play, but you get the point, right? Another cool thing about that is that if you're going right now, Unik is actually also taking the logs, which means that if right now we will go to the same IP address that this Minecraft is running on, like this one, for instance, and put it here in a regular browser, we put it in 9967, and we run logs, you will discover that I have the logs of the Minecraft. So basically, everything that happened in the Unikernel, we know, which means that we can debug. That would mean that we can audit trail and so on. Yeah, just going to leave this one, whatever, back to the game. Or I want to disconnect. You will discover that if I refresh it, the information is here, right? So basically, everything that's happening inside your application, you can get. The last thing that we're going to do is a quick demo of Kubernetes, just to explain how it works, how the integration there is working. So I have another machine here. And what I'm going to do is connect to it. And what I'm going to do right now is I'm going to show you that I have a dashboard of Kubernetes. And there's nothing running there, right? There's no Unikernel or anything or container running on this pod. And then what we're going to do is come here and just run it. So I'm just asking for three containers to run. Well, not container, Unikernel in that case. I'm coming here, and you will see immediately that that's happened. Now, what we're going to do next is we come here, and we will do Unik here right now. And we see that we have 3 instances. We can just go, just for a heck of it, and look what I'm running there. And you will see that this is a Go asteroid game or something like that. So I don't know if you're familiar with this game. You can do stuff. I don't know how to play this game. Here you go, and I'm killing stuff. Okay, so this is what we're running. And what I'm going to show you right now is we're going to kill from Unik one of these instances specifically, and then show you how Kubernetes is bringing it back. So what I will do, I will have here, once again. Cool. So let's take this machine, for instance. It's the same thing. I just want to show you watch. So what we're going to do is we're going to connect to the same machine. I will run watch Unik PaaS, that we will see what we're having here. So you see 3 instances. Now I'll go here and I will do Unik. Oh, come on. My machine died. No. 1 second, my machine died. Okay. Unik. Delete instance minus instance equal, and we're taking one of them, just doesn't matter which. And then I will do minus force to force killing. And what we're doing now, we're going to kill this one, and we will show you here that one of them dead, so we have only 2, and you will see Kubernetes immediately brought it back, right? So that's another demo, the integration with Kubernetes. I think that's what we have. I don't know, we probably don't have time anyway. So is there any question? Any question?
We have time for a few questions if anyone wants to come up to the mic.
So this all looks fantastic and really, really cool.
Yeah.
But it also looks really intimidating still, as somebody who's really just started using Docker in our infrastructure and working with our devs. Something like this looks like something I'd have a lot of trouble convincing them to even look at, because Docker is everywhere and stuff like that. So are there resources set up, like a wiki or something like that, that kind of dumb it down a little bit, for lack of a better term?
Yeah, so I mean, first of all, you can come to our, first of all, I can help you. Second of all, there is our Slack channel, and as I said, like people coming there, oh, I don't know, nothing is working. By the way, it's not that complicated. To install Unik is as simple as git clone and make. That's it. Everything is be done for you, because what we're doing is we're actually leveraging Docker to build the environment when we're building the Unikernel. So it's extremely, extremely easy. So that's one thing. The second thing is that I think that the next thing is to build tooling, right? To be fair, it's a new space. Mm-hmm. So there's going to be a lot of investment of building tooling to make it easy, because in the end of the day, I don't want you to need to deal with it. Right? What I need you to do is to push code to Kubernetes, or push code to Cloud Foundry, or push it to Docker Swarm, or do something very, very simple, and everything will be as a magic behind it, right? Because in the end of the day, today, what are really you doing with Docker? You're not just running Docker container. You're usually running some cluster with application and so on. So I think that's why it was very important to me to show how it's going to work, right? Yeah. It's going to be very, very clean and beautiful the way you're doing Docker. And by the way, the Kubernetes integration that we did, you can run container and Unikernel. We're not thinking that every application needs to be run on this. Mm-hmm. But think about the money that you're saving by actually not running this operating system, guest operating system that you don't need everywhere. It's a lot of storage, right? It's a lot of performance to debug it. Where is in the stack that I have the problem? Is that in the operating system? In my application, in the hypervisor, too much complication. If we will move what we don't need, it will be so much easy to understand what's going on. So that's what we're trying to do here.
Awesome. Thank you.
Thanks.
Hi, thanks for that presentation. Thanks. I enjoyed it. What I struggle with is kind of the basics. Like, it just seems totally crazy to say, like, we're going to throw away this, especially, throw away Linux, and, the TCP stack and the IP stack in there. Like, that's like 20 years, 30 years almost of people finding bugs and making the networking work. And to say that we're just going to rewrite it real fast.
So we are not rewriting a lot of the stuff. We're leveraging. That's the beauty of it, right? For instance, NetBSD, it's a operating system that people did the same thing with it and make it better. We're leveraging that. The only thing we're doing is we're taking what we need from this operating system, and then instead of taking the permission check and all the mess that there is there, we're adding a little scheduler and a little bit of memory management, and that's it. Because that's all you need. So why do you want all the rest, right? So we are leveraging what we need. That's why I think that runtime is better than other Unikernel, or reinventing it, right?
Okay. That makes more sense.
Hi, thanks. I have a coworker who's very interested in playing with Unik. Is your presentation available on the USB, or is there anywhere else that we can get more information?
It's in SlideShare, and you can see that talk actually. The beauty of it is that this is really actually getting hit, so I think I'm probably talking every conference that you can imagine in the last 6 months. So go online and just look for me. You will find that, and SlideShare, I put it there.
Great, thank you.
Awesome. And again, reach out to the Slack channel or something if you need help. We'll help. Okay, cool. Cool.
Any more questions?
Awesome. Thank you, guys.
Thank you.